Good day, everyone. My name is Dion Geverth. I'm a student at the Namibia University of Science and Technology, currently in my final year, pursuing a bachelor's degree in computer science with a specialization in software development. And in this demo video, or this short video rather, I'm going to show you guys about my proposal implementation for this hackathon, this Ballerina hackathon, and the project that I came up with and how I came about to implement it on a small scale at the moment. And just to see kind of the idea and the demonstration of ballerina concepts and ballerina technical tools on implementing this. And so the project that I built is called a smart vehicle to vehicle communication system. And this means as vehicles travel on the road, they're going to be sharing their real time information. And by this, I mean when the vehicle is on the road, there should be like a system on the app that tracks or that is able to track the vehicle's information, such as the speed at which you're driving and perhaps the color of the car, the name of the car that's already stored in the system on the app, and the location, the geolocation of where you are in relation to the coordinates, specifically at which position or which juncture are you when you're driving your vehicle. So now it's going to be communicating from your vehicle through the app or through the system to other uh, cars that are also driving on the road. So everybody with the app and driving will be able to actually see. So let me say I am driving my car on this particular road, wherever it is. So I should be able to receive alerts through the application. Now, this application is going to be able to notify me via a voice to say that, no, there's a car coming from which direction? From your front, driving at a certain speed, specifically, or specifying that speed. And it will be able to tell me that, no, you need to slow down or drive at this speed, or this is what you need to do. This car is far or is this far away from you. So it's just kind of vehicles communicating with each other. But at the moment, it's very small scale. And the cars that I'm utilizing for this simple system are simulated cars. So basically, just dummy data, posting data manually from the application front end to the back end. So the architecture now of the whole application. So I'm going to start with the application or the architecture of the whole application before I disintegrate down to go to uh, the architecture of now Ballerina, the backend itself, and where it comes in. So the application is composed, or the system is composed of an application in React Native, which is like just a normal app, iOS and Android app, a simple app that is then serving as a front end, communicating with who? The backend. Now the backend is encompassed by Ballerina, is running. The whole code is in Ballerina, and we have services on the backend. So the architecture that I'm using on the backend is called a microservices orchestration or microservices architecture, where I have distinct services for different purposes, but they're working together to perform a particular task. So I have four services on the backend. So if you can see here, the code that is open here. So I have four services. I have a folder called services. And then if you open it, I have an alert service. I have a notification service. I have an orchestration service, and I have a vehicle service. And I'm going to explain a little bit about what these services are doing here and how they are communicating with each other. It's microservices, by the way, because it's services or different services communicating with each other to work on a particular goal or to do a certain to accomplish a certain task, rather, if I may say it that way. So, first of all, if you can see the vehicle service, or let me start with the orchestration service. So the orchestration service is like the brain or the central hub for our entire backend application or Ballerina application. So this orchestration services or service is the one that connects or allows different or the other services to communicate with each other. So they all pass through the orchestration service. So it's microservices orchestration. So they're all passing through this orchestration service. So it's the center for it. So now to break it down into simple terms, so when the application from the front end running in React Native sends data, posts data in real time, this data is then received by who? The orchestration service serving on this port. So as it receives this data, it will then do what? It will then run this post. So there's this post, and as you can see, it's also a combination of restful endpoints or so, or restful, yeah, endpoints or so. The post, the gets, and all of that, they are all integrated in this. So it's the post request that's going to be done by the orchestration service as soon as it receives that data from the front end. And that data is a data being simulated on the front end of the vehicles that are running on the map. I'm going to demonstrate better visually on what I'm talking about. But basically, it receives that data and then it poses data to this endpoint, to the track and alert, and then it posts it to this URL, by the way, or to this endpoint, the vehicle track. Now, the vehicle track is where? This is this service. So meaning the orchestration receives and then it sends to this vehicle service with this post request. So this is not all the orchestration service is able to do. So it's able to post this data, but then it's also able to post, what is it? The step two, to post or to send the vehicle data to the alert service. So the step one would be to send this vehicle data to the vehicle tracking service, which is this one. And then the second step is to send this vehicle data, the same data, simultaneously to the alert service, which is this service. So you can see the orchestration service is like the center of everything. And as you can see, it's using these external services, meaning it's using the vehicle client service, which is serving on this port 8080, and then the alert client on this 8081, and then the notification client on this 8082 endpoint. So what's happening between these endpoints is that when the orchestration service receives this data, it's then able to send this data to the vehicle tracking service, right? Now, what is being done to the in the vehicle tracking service? So here it's going to receive this data and save this data where? In this data structure or in this data type called a map, a vehicle map. So it's going to store the data it receives from the orchestration service in here, in this map. So it receives the data and then it stores that data. And then this is another method that's the request that can be used to get all the vehicle data. So this is what's happening in the vehicle data. So the orchestration service receives the data, posts it to this guy, and then simultaneously posts it to the alert service. Now, what does alert service do? So the alert service receives the data from the orchestration service and it's able to check the speed, meaning it's able to check if the vehicle, based on the information sent or received by it, is the vehicle speeding or not? Now, how do we know if it's speeding? If it exists a certain threshold that you have set here, which is 120 kilometer per hour, if I'm not mistaken. Yes, 120 kilometer per hour. So it's able to check if it exists this, then it means it's speeding and it needs to slow down. So once it detects that the vehicle is speeding, what does it do? It then sends back this data to the orchestration service. So the orchestration service, like I said, is like a center of everything. So the orchestration service then receives this data to say, okay, the vehicle is speeding from the alert service. So now, once it receives this data that this particular vehicle is speeding at this speed, now, what is supposed to happen? Now, we use something else or another term called the event-driven integration, event-driven architecture, or so, if I may call it that way. So, meaning it's based on real-time alerts. Now, we have what we call a WebSocket service or WebSocket Ballerina-based service, if I may call it that way. Now, where is it? Is this notification service? So, this notification service is a WebSocket service or base service that is able to receive the alert and is able to respond instantaneously to the alerts. That's why I'm calling it an event-driven integration. So that's basically what's happening between these services. They are all communicating with each other, and they are different services serving different purposes, but then they're all working together for one common goal, which is to, in the end, alert the user on the app front end to say, no, you're speeding, or there's a car that is coming from your front of this color at this position, and this is what you need to do, through a voice on the front end. So that's basically what's happening here on the services that I've created. So we have microservices architecture, and then we have event driven, and then we have WebSockets, and then we have HTTP request, and then we have yeah, and then we have RESTful endpoints. What else do we have in here? The orchestration service, which is like the center or the central hub of everything, coordinating the communication between the services. That's what's happening there. And if you look here, this is just a terminal that I've opened that is showing how I'm going to run each of the services. So this will run the vehicle services, this will run the notification service, this will run the orchestration service, and this will run the alert service. But now I'm going to demonstrate later. I just want to explain a little bit about the front end as well. So this is basically just a home page of the React Native application, and it's pretty simple. I don't want to go too much into detail about this because it's not part of the application. It's just to make my idea kind of visualized. But as you can see, it still sends the car data in real time to the orchestration service. So the orchestration is receiving this data from the front end through this method, or this through this post request with this data, right? And then after it receives that, it starts the simulation of the information. So it receives the data as an orchestration service, and then it sends the data to the vehicle tracking to be stored. And then every time we want to receive or to retrieve this data, we go to the vehicle tracking service, and then it's able, through that get method that we saw there, to retrieve this data for us. But then on the front end, we just have a map, and then we have a simulation of cars. They're not moving too well, but it's just to demonstrate my idea of what is supposed to happen with this application. And here I was just setting up a WebSocket connection on this endpoint, the notify endpoint. So basically, it's just the front end to interact with the backend. That's what's happening there. And right now, I'm going to go into now running this, and just to demonstrate to you guys how my idea is supposed to function and how it's working together, by the way. So this was just the theory part of it. So now I'm going to continue. So now we are going to move on to the running of the project itself. And I'm just going to run the services here. I'm going to run the service, or the vehicle service. I'm going to run the notification service. I'm going to run the orchestration, and I'm going to run the alert. I'm just running them at random to save some time because I don't have time anymore on the video. And so I'm going to wait for the services to run, and then I'm going to refresh the front end of the application in React Native so that it can start changing the services here. So as you can see, the vehicle service started running. It's waiting. Now the notification started, the orchestration started, and the alert has started. So now I'm going to refresh the application so you can see what is happening here. And then just watch what the terminal is going to do. So now the orchestration is supposed to receive that data of the car and then send that data to the vehicle service. We hope that is what is going to happen. Let's just wait for it. Okay, so first of all, it sent this data to this service. This service then received the data and then it stored it. So once it stored the data, it simultaneously, the orchestration sends simultaneously to the alert service. The alert service was able to detect that instead there was a speed at this, or there was a speeding at this specific speed, and then it sent it back to the orchestration. The orchestration then sent the notification to the notification service, and then the notification service received that message here, and it was able to send it to the user that this car is speeding. So now I'm going to show you guys the interface of the application and how it's working together with this. So now I'm going to run the application itself. Let me just refresh it, the interface, and to see how it operates, how it looks, and all that. So it's refreshing now. It's a simple application, by the way, with the, or it's a mobile application.
So those are two cars driving, one driving at 100. As you see, this one started speeding up at 130
Warning, a
kilometer
red
per hour.
car is approaching at
And the alert is triggered.
130 km per hour from the south. Please be cautious. You are clear. The other vehicle has passed safely. The road is...
So that's just the idea at the moment, but I can always scale it up. Let me just rerun it again so you see clearly what's happening here. So there are two cars, one is blue, one is red. And then eventually they start at 100 km per hour, and then eventually one speeds up at 130, the red car. Just see what's happening. It started to speed up as it's arriving.
Warning, a red car is approaching at 130 km per hour from the south. Please be cautious. You are clear. The other vehicle has passed safely. The road is clear.